So we're going to start with the mean value theorem. First of all, we're going to talk about what is it. Simply put, it is AROC, or average rate of change, equals IROC, instantaneous rate of change, as long as you meet the key criteria. What is the key criteria? You have to have a nice, smooth, so differentiable function. So that means 1, we must be differentiable if this is x equals a and this is x equals b, then on the open interval a to b. So that means not including our endpoints. 2, we must be continuous. And if something is differentiable, then it will be continuous. So here we have the closed intervals including our endpoints. So those are the two things that must be true. If those are true, then AROC must equal IROC in at least one location on those intervals. So I'll demonstrate it graphically. You can see it. The average rate of change would just be the slope between those 2 points. So we would say f of b minus f of a all over b minus a. That's really just our y2 minus y1, x2 minus x1, but in the form of our function. So that's preferable. Well, we must be equal to our instantaneous rate of change, which is our f prime at some value c. So just to look at it, it looks like that's true, maybe right there. That's what the mean value theorem comes from. What about the name? Well, mean equals average. And this deals with average rate of change. So that's why it's called the mean value theorem. The average rate of change must equal the instantaneous rate of change. Let's talk about like a simple problem we can answer so far. For the graph that's drawn, in how many locations is the mean value theorem satisfied? So how many times? Well, we'll draw our average rate of change, slope between the 2 points. In how many locations would IROC be the same as that? 2. 1 in this vicinity and 1 in that vicinity. You can start to see the number of max and mins will decide this. What if we had that graph? Hopefully you can see. Now we're looking at 1, 2, 3. But the mean value theorem doesn't guarantee if we have something, let's say there's a cusp. This is not differentiable at our cusp, and you can see there are 0 locations because we're not differentiable. We don't meet this requirement, so it's not guaranteed. Doesn't mean we couldn't have any, but it's not guaranteed. That's the mean value theorem.